Let's practice a few more integration by substitution problems before we get into some more advanced u substitution problems. So we'll start with example 2 here. We would like to integrate 3 times the quantity 3x plus 4 raised to the 6th power dx. So the thing that you should kind of keep an eye out for that kind of helps you to know that we need to use substitution is generally that these problems, these integrals, will be a lot more advanced than something that we can just use the power rule with. If you look at a problem and say, I don't know how to do that, this looks a little bit complex, I've got this function of x being raised to the 6th power, that's a really big clue that we're going to need to use integration by substitution. To be honest, for the substitution method, you're looking at a lot of the same things that we use for the chain rule. And in particular, one of the things that carries over here is that the parentheses can really help you pick out what that inside function should be. In this case, u should be 3x plus 4, what's inside of the parentheses. So there's my first step. There's my inside function. My next step, once I have u, I need to find du. So I'm going to take the derivative of 3x plus 4, which in this case is just 3, and I'm going to multiply that by dx so that I can make my substitution. So what we have so far right here, we've said 3x plus 4, this is going to be u. Now, in the last video, it worked out really nicely that our du was kind of all grouped together. And here we've got 3 times dx. Now, if I look at my indefinite integral, I've got 3 times 3x plus 4 to the 6th power times dx. Now, it doesn't really make that big of a difference the order that we have these in because we can multiply in any order that you like. So if you wanted to, if it will make you feel a little bit more comfortable with the substitution, you may want to take a step just to rewrite this. I'm going to rewrite this as 3x plus 4 raised to the 6th power times 3 times dx. And now it's very clear to me, oh, the 3 dx, that's right there. That is going to be my du. So it becomes much easier to see. I think it's a good strategy to start off by kind of rearranging the terms if you feel like you need to. It makes the substitution much, much easier to see at times. Then next, we said that 3x plus 4, that is going to be my u. So it looks like everything is accounted for. That's great. We can make our substitution. When we do that, we'll have something that looks like u to the 6th du. So now I've gotten everything written in terms of my new variable u. And compare the integrals again. We started with something that was pretty complex. We had a binomial being raised to the 6th power, and now it's just one variable being raised to the 6th power. We should end up with an easier looking integral than what we began with. That's the whole point of this process, is to take something that's hard and make it a little bit easier. So now that I have this slightly simpler integral, I can just use my power rule in this case. So I'll add 1 to the power. This will be u to the 7th power divided by my new power of 7. Plus, of course, we can't forget about our constant of integration c. And then in our last step, we'll take our 3x plus 4 and plug that back in for u. Because if I start with something in terms of x, I'd like to end with something in terms of x. So I'm going to have, in this problem, 3x plus 4 raised to the 7th power divided by 7 plus c. There is my indefinite integral. There is my general antiderivative. So let's look at one more real quick before we wrap this video up. In the next example, I have the indefinite integral. I'm looking at the cubed root of 2x squared minus 4 times 4x dx. So again, just like last time, I'm looking for what is the inside function. And I'm looking for, sometimes I can think about that as what is the highest power of x, or what is the most complicated part of this function. And in this case, I think that the 2x squared minus 4 would be a really good bet here. So I'm going to take u equals to 2x squared minus 4. So there is my u. Once I have that, I can find du. Du, in this case, the derivative of 2x squared minus 4. That's going to be 4x times dx. So let's go ahead and see what we have now. We've said 2x squared minus 4. That's going to be my u. In this problem, I don't need to do any rearranging. I've already got 4x times dx, so that means that that part is going to be my du, because that matches up perfectly with what I have over there on the right-hand side in red. So at this point, I'm ready to go ahead and make my substitution then. We've got the indefinite integral of the cubed root of u times du. So we started with something that was fairly complex looking, and we've managed to boil it down to a single term, which is much nicer for us to work with. Here in this case, we do still need to do some rewriting to account for that cubed root function. Using our exponent properties, though, we know that we can rewrite that as u to the 1/3 power du. And now, at this point, we can go ahead and use our power rule. So we can add 1 to our power and divide by that new power. So if I add 1 to the power, I should have u to the 4/3 power. And my next step would be to divide by that new power of 4/3, but I don't really like that. I don't like dividing by a fraction. It kind of looks ugly to me. So I'm going to simplify that, because I know that another way to divide by a fraction is to multiply by the reciprocal. I'll multiply by 3/4. We've done our power rule, which means we've integrated, which means we need our constant of integration c. And now that we have that, we can go ahead and take our u and plug that back into our solution. So that should look like 3/4 times 2x squared minus 4 raised to the 4/3 power plus c. So this is our general antiderivative for this particular problem. Now, in the last two examples, and all of the examples that we've looked at so far, the du that we found has matched up with exactly kind of what else is left over in our problem, in our integral. That will not always be the case. These two things will not always line up right. So in the next video, we're going to see how do we deal with it? How can we kind of compensate for the fact that those two don't always match up right? What can we do to still be able to solve those problems?